This worksheet works with z-scores again. You'll notice it's the same thing, right? The z-score, how many standard deviations away from the mean any individual is. This is also called the random variable, right? So this is a guy that scored 79 on a test or, 32 on a test. And this is the population mean or the norm, right? Everybody's average. This is the population standard deviation. So you'll notice that we're going to have to find the area under the curves with a different formula here. This one does not have an S between the M and the D. So this is norm dist. But what this does is it makes the z-score for you and then finds the area for that z-score. So that's what this new application is going to be. Okay, so again, here is the formula that we're going to use with real numbers instead of z-scores. That's how you remember to use this formula. So let's look at the first question. Here's all the data. The Calico Cat Company got a bunch of kittens. The weights are normally distributed. Remember, all this stuff only works if the data is normal. Remember that. Okay, so the average is 2.40 pounds. The standard deviation is 0.36. Okay, so a little girl she blindfolds herself and reaches in and pulls out one cat at random. Again, at random is important. She takes it home and she calls it Statistics Kitty. So what's the probability that that kitten is going to weigh over 2.76 pounds? So let me show you the picture of that. So if the mean is 0.240, that's what this line right here would be. Right, that mark right there on that number line would be 2.40. And she wants to know what's the probability that it's going to be over 2.76. So if this is 2.40, 2.76 would be somewhere around here. And it's going to be greater than, so we're looking for the area of this chunk of the curve right here. So if we draw a straight line up here, we want the area to this. So let's go ahead and use our magic Excel. Before we hit the Excel, let's figure out which one of these we're going to use. So the question is, what's the probability that the kitten will weigh over, right? So this is a greater than, probability that it's greater than, and we're going to use that one. So this is the one we're going to use right here, okay? I suggest simply you copy it and paste it. Go back to the formula bar, paste it back in, paste. And there's the formula. So when you click the box again, it'll just basically tell you what each one's mean, what each individual means. So A is your random variable, and in this question it's 2.76. Correct. And the mean is the standard mean, is the given mean, and that's 2.40 from the problem. This is the standard deviation, and that's 0.36. And we always just leave it to call it true, and this should give us our answer. Bam. Again, this is a greater than, so it gets subtracted from 1. So in other words, she's got about a 16% chance that that kitten will weigh greater than 0.276 ounces or pounds, whatever it is. Next problem, what's the probability that the kitten will weigh under 2.4 pounds? So again, this is a less than. Less than, we're going to use probability of less than. That's the first one. That's the top one. So we're not subtracting anything from 1. And I'm hoping you'll notice that this is a trick question because 2.40 is the mean. But let's just go ahead and start from scratch. So I pick a cell, any cell. I go to the function bar. Make sure I'm in statistical. This time I'm going to norm dist. No S. Norm dist. Where are you, baby? Norm dist, right there. Click. Okay, Rx is the random variable, so that's the number, that's the individual piece of data that we're asking about, so it's 2.40. And the mean is 2.40. And the standard deviation is 0.036. And 0.36, not 0.036, 0.36. And we always put in true. Click continue, bam. So that's the probability that the cat will weigh less than 2.40. So next one, here's another one of those in-betweeners. What's the probability that the cat's going to weigh between 2.31 and 3.0? So that's this formula right here, right? Between two given values. So I'm simply going to use this formula. Let me highlight it again. And shoot, I'll just pick a cell, any cell, paste it in there. Boop. So our B is our bigger number, and that was 3.00. And our mean was 2.40. And our standard deviation is 0.36. And it's true. And our second value is the smaller value, and I already forgot what it was. 2.31. Everything else should be the same. 2.40. 0.36. And true. Just hit enter. So there is the probability that she's going to get a kitten that weighs between 2.3 and 3 pounds, right there, a little over 50%. All right, next question. 30% of the kittens should weigh under what weight? That's a different type of problem. It kind of shifts around in your brain a little bit, but here's the formulas up here with proportions or percents above or below something. So we're looking for the 30% under what weight? So 30% under what weight? So we'd find the area underneath the curve of about 30%, which would be, I don't know, right around here. This little chunk right here looks like roughly 30%. So if we had a z-score of 0 here, this would be -1. So it's somewhere between -1 and -2 z-scores. But they want real weights this time. So this is going to be 2.40. That's the mean. Minus 1 standard deviation, this would be 2.04. Minus the second standard deviation, this would be 2.78 or something like that. But we're going to use Excel to the rescue. We're going to go ahead and pick a cell, any cell. Let me get rid of these guys. And let me take a quick look at the formula again. So we're looking for a 30% will be under. That is us right here, right? Remember, so if it's over, you always subtract something from 1. So here it is right here, norm inv. Pick a cell, any cell, go to the function bar, make sure you're in statistical, scroll down to norm inv. Where are you, man? Right there, norm inv. And the first thing is the probability. So, and again, all these are less than, so we want the probability of 30%, and Excel does recognize percentages, so you can do that or put it into a decimal. The mean is 2.40. Standard deviation is 0.36. Click OK. Bam. That is the answer. Let me make it bigger for you. So in other words, 30% of the kittens should weigh less than 2.2 pounds. Next question. The top 5% should weigh over what? Okay, this is the heaviest of the cats. So we're going to go for the above it. That's this one. Okay. So we're going to subtract the probability from 1. So in other words, 5% above is the same as 95% below. That z-score would be identical. Okay, so, but we're going to go up here, and so we're going to do 1 minus 5%. And everything else is going to stay the same. And so it's about 3 pounds, 2.99 pounds. So in other words, the top 5% of the kittens should weigh right around 3 pounds or above. And in this last one right here, this one's kind of tricky, but I'll show you real quick. So what's the percentage of the kittens who will weigh between 2.1 and 3.1? So I tried to trick you, my bad. But basically, this is just like this one up here. What's the probability that the kittens will weigh like that? Probabilities and percentages are the same thing in this context. Okay, so what's the probability that the kittens will weigh between these two values? We can simply do that one again. And we're just going to pick a cell, any cell. Let me get rid of this, not to confuse you. So we would look for norm dist again. So equals norm, give me norm dist, no S, norm dist, norm. There you are. Boom. And again, you go with the smallest value first, which was, I already forgot, hold on, 2.1. 2.1. And the mean is 2.40, and the standard deviation is 0.36. And of course, this is true, true, true. Hit OK. So there's the smaller value. So I'm going to take a big shortcut, copy, and then I'm going to paste it back in and put a subtraction mark between them. And then I'm going to change this one on the left to the bigger one. And I believe that was 3.1. So this first part right here gives you the probability that it's going to be 0.31 pounds or less, which is most of the curve, right? That should be close to 100%. And it's going to subtract out the probability that it will be less than 2.1. And whatever that answer is the difference between the two. So in other words, she's got a 77% chance that kitty, statistics kitty, will weigh between 2.1 and 3.1 pounds. So that's it. And I know this is harder than it looks, but stick with it. You'll get it. All right, MGZ out.